Folks, good evening. I've had a couple questions over the last day or so about this discussion post. I'm not sure if you saw it or not, but over the weekend I sent you all a little screenshot with some hints that I thought would be helpful. But what I'm going to do to add to that is go through this little tutorial here. And that way that if anybody needs to get this finished up, it'll give you a day or so to look at this and make sure it's clear. At least on how we're going to complete this chart. And I think from there forward, this should be a fairly easy drill. The first thing that you are asked is looking at this quadratic equation, which models the motion of a ball that is thrown vertically upward from the top of a building that is 110 feet off the ground. And the first thing you are asked about this, and what you'll notice here, is based on the fact that this position function, this function of t, is quadratic in nature, and we can see that by the fact that this variable t is squared. It's going to ask you about the parabola, the visual interpretation or orientation of the parabola itself. And what you're looking at to determine whether that opens up or down is the coefficient of this t squared term. And the coefficient happens to be negative 16. And given the fact that that coefficient is less than 0, it means the parabola will open downward. So it looks like an upside down, sort of a rounded off V or a U or whatever you want to call it. But a parabola, if you can call it, I follow my cursor, it's going to be in the shape of this upside down, kind of this upside down U or whatever. But again, it's oriented upside down, or it opens downward. Because this coefficient of the squared term is negative. And so the first thing that we're going to do here before we get to the questions at the bottom, and I don't have the questions, but I just took a piece of this graph, or I'm sorry, this table, and did some math to show you. Just make sure it's very clear what's being asked for here, and that way you can finish this up. So in these first 4 lines here, what you're given is you're given values of t, and what we want to know is that for these given values of t, how high is the ball off the ground? And we can find that out by substituting these given values of time for the variable t in the equation here. So I've done a couple of them here. Let me let's see, scroll this down just a little bit. So I've done the lines here for 0 and 1. So essentially here, in order to calculate s of t, what we're going to do is we're going to substitute 0 for t in this equation, and then we're going to just crunch the numbers here and find out what the value of the function is, or essentially what the height of the ball is at some given time t. So when t is 0, I have substituted it here on this line, and in order to make essentially to do the math here, I'm going to substitute 0 for t. So everywhere on the right hand side here where I see t, I substitute 0, and what I find is that times 0, the ball is 112 feet off the ground. And that makes sense because if no time has elapsed, the ball is still in somebody's hand, and so it is 112 feet off the ground. So that makes great sense. Again, the interpretation here, what we would say simply is at time equals 0, the ball is 112 feet off the ground. That would be sufficient for the interpretation here. Similarly, with time equals 1 second, the math is the same idea. We are just going to substitute 1 for t, and that means on the right-hand side here, wherever we see t, we're going to substitute 1. You can see I've done that twice. And let's see, if I go down to the second line here, I'll still have 112 plus 96, and then minus 16. And then if we do all the math there, we're going to get 192 feet. So the interpretation here is at time equals 1 second, the ball is 192 feet off the ground. And that means, the person who's standing on top of the building has released the ball, and after a second, it has basically climbed about 80 feet. So that makes reasonable sense. So what you're going to have to do is go back here, and you're going to have to finish this up for 0.5. You'll be substituting 0.5 for t and doing the math, and then also for 2. Now, when we get down to this other section of the graph here, notice now that we're given values of s of t. Essentially now, instead of being given time like we were given in these first 4 lines, Now we're going to be given a height, and we're going to have to determine at what time t does the ball reach these particular heights. So the math works slightly different here. So since we're given s of t, what we're going to do is, based on the given parabolic equation, we'll be substituting 100 for s of t and then 200 for s of t. Now the question is, why do we have two values of 100 here? And hopefully it'll be very clear when I show you here, when I go down. So if I take this and I go down and I do my first piece of this here. So again, notice that on the on the left-hand side, I'm substituting 100 for s of t, and then in order to solve this, nothing's happening on the right at this point because I'm not substituting for t, I'm substituting for s of t. But in order to solve this, remember, it has to be put in standard form, which means I'm going to subtract 100 from both sides. And so on the left-hand side, obviously the 100 goes away. I'm left with 0, and then 112 minus 100 is 12. So essentially, I'm left with this quadratic equation right here. And what I want to do is I want to solve that. And I'll just take a very straightforward approach, so there's no concerns about factoring here. And I'm going to say I'm going to solve using the quadratic formula, and note there will be two values for t. And so since there are two values for t, we know that at certain times t, the ball will be 100 feet off the ground, or so we think. Because what's going to happen, so what I did here is, given this quadratic equation, I found a, b, and c, right? So the a term is the coefficient of the squared term. The b coefficient is, or the b value is the coefficient of t, and that's 96, and then c is the constant. And so what I've done is I've shown the quadratic formula here, and then I have substituted. So this would be the substitution you get. And of course, the plus minus here is what's going to give you the two values. So once you go through and you do this math, you're going to have two values for t. And I'm going to give you a little hint here. One of them should be a positive value, and the other one should be negative. And since we're talking about time, that negative value is really not going to make sense here. And so if you think about somebody standing on top of a building that's 112 feet tall, and then releasing the ball or throwing the ball up into the air, and then it goes to its peak and it keeps falling down, it's only going to reach 100 feet one time, and that's after it falls essentially 12 feet below the height of the building. So two values of time here when the ball is going to be 100 feet off the ground really doesn't make a whole lot of sense. So when you see this, one of the values will be positive, one will be negative. The positive value will make sense, the negative won't. When you do this for 200, you will get two positive values for t, and that would make sense because the person's going to throw the ball, it's going to go up, it's going to reach its peak, and we assume that peak is somewhere above 200 feet, so it'll reach 200 feet on the way up, and then once it reaches the peak and heads back down, it'll again reach 200 feet above the ground. So two values for t when the height is 200 feet should make sense. But I just want to make sure that that's clear on how we're working the table. And then the interpretation here will be, for instance, you're going to have one positive value for t here, and the interpretation will be simple to say the ball reaches a height of 100 feet above the ground at time equals t seconds, and that will be whatever positive value you find down here once you go through the math. And then the other one you can just say, obviously this one does not make sense since t is less than 0, right? So I think that that would be sufficient for the interpretation given the height of the ball. So listen, I hope this is helpful. I was hoping that the hint that I sent over the weekend would help, but I think a couple of you brought up some points here that I wanted to just make sure are very clear, and I think doing it through a video is helpful. But if you have any other questions, pop me a note tonight or tomorrow, and I'll make sure that they get answered. And if we need to extend this discussion board by a day or so, we can do that. But I just want to make sure everybody's clear on how to finish this up. Take care and have a good night.